We're here in Cuyahoga Valley National Recreation and Peninsula, and I thought, hey, we're here now, school's not out, time to learn. So I thought we'd take a little walk today and do a little geological walk to the Ledges Shelter. So let's go. Good afternoon, students. I know you think that when school's out, you're not have to learn anything, but I thought I'd give you a little video. We are at the Cuyahoga Valley National Recreation Area in a place called Happy Days, which is over by the Ledges. I thought we'd talk a little bit about some sedimentary rock. You know, sedimentary rock is formed when rocks, loose rock layers get squeezed together to form strata. And I thought I'd show you an example of this strata right here. If you look over here, we have some pretty soft sandstone. You can even grind away the sandstone. We know that was what happened when sand, as my lovely assistant here, as sand gets rubbed together, squeezed together, it forms solid sandstone. And then if you look here, we see a layer of conglomerate, which is what happens when little pebbles get stuck in the sandstone. And then we see somewhere sandstone here. So we know there was a layer somewhere along there with some fast moving water, moved some pebbles, made a layer of pebbles, and then new strata piled on top. So this is called the geologic column when you have different layers of rock all together. All right, you've got an example here, students, of a rock that was obviously together at some point. Now this would not be a divergent boundary, there's not a fault line here, but you notice the erosion caused it to crack, the ice gets in the middle, start forming cracks, and over long periods of time, this one big rock eventually split into two, so it kind of forms together a jigsaw puzzle. Kind of like when Alfred Wegener looked at the earth and said the continents look like a bunch of puzzle pieces. Well, these look like they should be together because they were together. All right, we are at the Ledges up in Peninsula, Ohio here, and if you take a look, what we have is you have a cliff. We've got a whole valley down here that was caused by, remember that uniformitarianism where the water came through, kind of like a little mini Grand Canyon. So if you look, we're at the edge of a cliff here, and if you look down, it's about a 50, 60 foot drop, and you can see the people walking on the bottom. This is uniformitarianism. But at certain times we had big cataclysmic floods that also caused a lot of erosion too. So this is Cuyahoga Valley, this is the Ledges in Peninsula, Ohio.
That's the question.
Go ahead, Abby.
Why are there different colors of sand?
Well, that's an excellent question, young lady. Remember in class we talked about the iron deposits that were found at the right before the Precambrian time, the iron bands. Well, this would be an example of iron bands right here. This was probably deposited about 1 billion years ago, and we see the iron deposits right here in the soft sandstone. I know we left off in class talking about uniformitarianism and catastrophism. This is a good example of uniformitarianism. We got layers and layers of sand that's been squeezed together over long periods of time. We got some loose sand here. We know this loose sand over time, when you squeeze it together, will form sandstone. And they believe that a big flood came through here many thousands of years ago and helped carve out this valley, which was also an example of catastrophism, when a flood comes through and does sudden geological changes. Okay. In some cases, we have something called erosion weathering, which is when rock layers are kind of eroded away by different processes like ice and water and wind. We see some examples of what's called honeycombing. And if you look across here, you'll see some big divots in the rock. And that's what happens when these little pebbles get eroded away and erosion takes place. And you see a bunch of little pebble pock marks here in the rock. So this would be an example of erosion and deposition.
How do you tell the difference between an old stream and a young stream?
Now, I know we haven't got to this point of the year yet, but we're talking about erosion. This is what we call a young stream. It has a large vertical fall. You'll notice it starts at the top and comes quickly down. It's also cuts a little V-shaped valley, and the stream runs straight. There are very few bends in a young stream.
What a great view.
It is a great view, Abby. If you look in the distance, Again, it's kind of like the Grand Canyon. We had, I think, an ancient riverbed formed this valley down here, and over time it spread out, and over thousands of millions of years we form a valley, okay, from uniformitarianism. Come on, Shirley.
How do you tell the difference between coniferous and deciduous forests?
So, a great question, Abby. So, you notice none of these leaves are falling. They are all still on the trees. This is a coniferous forest because they stay green year-round. Now, a deciduous forest would be maple trees, pine trees, and oak trees. What is a deciduous forest?
Good question, Sam. A deciduous forest is a forest where the leaves fall and they aren't green year-round, like maple trees, oak trees, and pine trees.
Not pine though.
All right, we're going to get to this point in weathering, what we call weathering. This is an example of physical weathering. We have cracks in the rock. We know that water, when it freezes, expands. So you see an example right up here. You can see some large cracks in the rock there. As the water gets in the crack and it freezes, it'll expand and get a little bit bigger, cause the rock to be divided up. And year after year, eventually you'll have something like over here, where you'll notice that this rock here is completely split off, and gravity's pulling it to the bottom of the valley. All right, I want to show you guys a little bit of erosion, stream erosion here. This is probably an old stream, maybe in some places a mature stream. But whenever we have a corner here, if you'll notice that the inside of a corner, the water travels slower. So we have like a deposition, like a sandbar here. And then the outside of the stream, okay, always erodes the outside of the stream. The water's moving faster over here, so we have erosion. The water slows down here, and we have a deposition. River erosion. What we have here is we have a part of something called an old creek, okay, an old river. The old rivers have something called meanders, which means they have big S's that zip their way back and forth. This is called an oxbow. This area in front of me is called an oxbow because we have an entire, almost a C shape here. Again, if you could see it, you'll notice the inside of the curve is all deposition. It erodes on the outside. So the water travels faster on the outside, so we see erosion around the outside, big rocks there, and then we have sand on the inside where the water travels slow. And I look for some fossils today. Sorry, I didn't see dinosaur fossils today. So I'll try harder next time. Okay, Abby?
Yeah?
What kind of rock do we find fossils in, Abby?
Sedimentary.
Sedimentary rock. Go. All right, so we have an example here of an old stream. You look at all the way at the edge, you'll see erosion, and then you'll see a big S shape right here, and it meanders back and forth. Okay, this is an old stream right here. Eventually, this part right here, eventually it'll cut across right there, and this will become an oxbow lake right down here. It will get cut off, and the stream will cut right across this little area right there. So this is called an old stream.
What a wonderful day in this national park. I hope we can come back another time, can we?
I learned so much about rock formations today.
Hope you enjoyed it, kids. Miss you guys, but hopefully see you soon. All right, goodbye.